Most people still think local AI means one thing. You install a chatbot, you download a language model, you type a prompt, the model replies. That is local AI. But that definition is already too small because local AI is turning into something much bigger than a private chatbot. It is becoming a full stack language models, vision, voice, image generation, video generation, face recognition, speaker diarization, real-time audio, distributed routing, usage tracking, prompt caching, API compatibility, admin dashboards, multi-user systems, and one of the projects pushing hardest in that direction is Local AI. Local AI describes itself as an open source AI engine that can run models for text, vision, voice, images, and video on your own hardware without requiring a GPU. And if you look at how quickly it has been shipping, the story is not just, here's another way to run a model locally. The story is, local AI is becoming a platform. So in this video, we are going to look at what local AI is, why its recent releases matter, why all-in-one local AI is such a big deal, and why the future of private AI might look less like a single app and more like your own local AI server. The first wave of local AI was mostly about proving that it worked. Could you run a large language model on a consumer machine? Could you make it respond at a usable speed? Could you get it running without building your own machine learning stack from scratch? Tools like llama.cpp, llama, LM Studio, and others made local language models accessible to normal people, and that was a huge shift. Suddenly, you could download a model and run it on your laptop or desktop. You did not need an API key. You did not need a cloud account. You did not need to send every prompt to a company server. But the early experience was still mostly centered around chat. You had a local model, you talked to it. Maybe you used it for coding, maybe you connected it to an editor, maybe you built a small local tool around it. That was useful, but it was not the full AI experience people were getting in the cloud. Cloud AI tools were adding voice, vision, real-time conversations, agents, tool calling, file workflows, image generation, video generation, team features, administration, logging, and for local AI to become genuinely competitive, it needed to move beyond here's a model. It needed to become here's a stack. That is where local AI gets interesting. Local AI is not just a chat interface, it is trying to be an AI engine. The idea is that you can run many different kinds of AI workloads locally or on your own infrastructure using open source software and local models. That includes language models, it includes vision models, it includes speech to text, it includes text to speech, it includes image and video generation, it includes open AI compatible APIs, it includes support for different backends, and it is designed around the idea that AI should be something you can self-host. That word matters, self-host, because once you self-host AI, you change the entire relationship. You're not just renting a model, you're running the infrastructure. You can decide which models are allowed, you can control where the data goes, you can add authentication, you can track usage, you can connect internal systems, you can run it behind your own firewall, you can tune it for your own workflows. That is why local AI is interesting for developers, small teams, enterprises, and privacy-focused users. It is not trying to be the prettiest AI app, it is trying to be the local AI layer underneath your apps. The most interesting thing about local AI right now is how quickly the feature set has been expanding. Recent updates have added or improved things like voice recognition, face recognition, speaker diarization, video generation, distributed routing, usage attribution, and prompt caching. That sounds like a random list until you step back. Then it starts to look like a platform roadmap. Voice recognition means local systems can listen. Text-to-speech and real-time audio mean they can talk back. Vision and face recognition mean they can process images and identity-related workflows. Video generation means local AI is moving beyond text and static images. Distributed routing means workloads can be spread across machines or replicas. Usage attribution means teams can track who is using what. Prompt caching means repeated system prompts and repeated workflows can get much faster. These are not just fun features, they are the kind of features you need when AI becomes part of a real system. If you're building a local AI assistant for a team, you need authentication and usage tracking. If you're running multiple models, you need routing. If you're building a voice workflow, you need audio. If you're running repeated prompts, you need caching. If you're handling private files, you need local control. This is why local AI feels different from a simple model runner. It is becoming a toolkit for building AI products and workflows without handing everything to a cloud provider. Prompt caching sounds boring. It is not boring. It is one of those features that can completely change the feel of an AI system. A lot of AI workflows include repeated instructions, the same system prompt, the same style guide, the same coding rules, the same role description, the same business context, the same safety instructions. If the model has to process all of that from scratch every single time, the workflow gets slower and more expensive. Prompt caching lets repeated prompt content be reused more efficiently. For local AI, that can be especially important. Local hardware is more limited than cloud infrastructure. You do not have infinite GPUs sitting behind every request, so every efficiency improvement matters. If repeated prompts collapse from painfully slow to much faster, local AI becomes more usable, and usability is everything. People do not adopt local AI because it is theoretically private. They adopt it when it is private and fast enough and reliable enough to use every day. Prompt caching is one of the features that helps move local AI from cool demo to daily tool. Hey, don't forget to like and subscribe for more like this now. Back to the video. Usage tracking is another feature that sounds boring until you imagine using local AI inside a real organization. If one person is running a model on their laptop, usage tracking may not matter much. But if a team or company runs local AI as a shared service, suddenly it matters a lot. Who is using which model? Which API keys are generating the most load? Which users are consuming the most resources? Which workflows are expensive? Which models are actually being used? Without usage tracking, self-hosted AI can become messy very quickly. With usage tracking, it becomes manageable. This is part of the broader pattern. Local AI is maturing. The early conversation was, can I run this model? The mature conversation is, can I operate this system? Those are very different questions. Operating an AI system means managing users, costs, logs, routing, reliability, security, and performance. Local AI adding features in that direction tells you the project is not just chasing demos, it is moving toward production workflows. The moment local AI moves beyond text, it becomes a lot more interesting. Text-only AI is useful, but humans do not live in text-only environments. We speak, we listen, we look at images, we recognize faces, we work with video, we use screenshots, documents, recordings, cameras, and meetings. Cloud AI platforms understand this. That is why they are racing toward multimodal assistance. Local AI has to follow. If local systems can handle voice recognition, speech, image understanding, and video generation, they become far more capable. Imagine a local assistant that transcribes meetings without sending audio to a cloud service. Imagine a security-conscious company doing internal image analysis on its own hardware. Imagine a creator generating rough video assets locally. Imagine a private personal assistant that can listen and respond without every interaction being routed through a third party. The point is not that local models will beat every cloud model in quality. The point is that some workflows care more about privacy, control, and ownership than absolute peak quality. And for those workflows, local multimodal AI becomes very attractive. There's another important idea here. Local AI does not always mean one laptop. People often imagine local AI as, can my computer run this? But local can also mean, can my organization run this? That might be a workstation. It might be a local server. It might be several machines. It might be a private cluster. It might be edge devices connected to a central system. Distributed routing matters because it allows local or self-hosted AI to scale beyond one box. If you have multiple machines or replicas, you need a way to send requests intelligently. Some machines may have more memory, some may have GPUs, some may be better suited for certain models, some may be overloaded. Routing makes the system more flexible. And flexibility is critical if local AI is going to grow from hobby usage into real infrastructure. Again, this is the big theme. Local AI is not just AI on my laptop, it is AI under your control. Sometimes that control lives on a laptop, sometimes it lives on a private server, sometimes it lives inside a company network. The important part is that you decide an all-in-one local AI stack is powerful because it reduces friction. If you need 5 different tools for text, speech, image generation, video, and APIs, the workflow becomes complicated. If one engine can coordinate many of those capabilities, experimentation becomes easier, developers can build against familiar APIs, teams can standardize around a single service, users can try different models and modalities without rebuilding the stack each time. That does not mean one project should do everything perfectly. It means a unifying layer can be extremely useful. Think of it like a local AI control plane. You still choose your models, you still choose your backends, you still decide what hardware to run, but you get one place to manage the experience. That is the appeal of local AI. It gives people a path toward owning their AI infrastructure without becoming a full-time machine learning operations team. Of course, local AI still has real limitations. Hardware matters, memory matters, model quality matters, driver support matters. Setup can still be confusing. Some workloads are slow without a GPU. Some models are too large for consumer machines. Some features require careful configuration, and the best cloud AI systems are still ahead in many tasks. So this is not a magical replacement for every AI product. Local AI does not make your laptop equivalent to a frontier data center. But that is not the bar. The bar is whether more AI workloads can move under user control, and the answer is increasingly yes. Not all workloads, but more of them. Enough to matter, enough to build around, enough to make local AI a serious option instead of a curiosity. Local AI is interesting because it shows where local AI is going. Not just one model, not just one chat window, not just a private toy for enthusiasts, a full stack, text, voice, vision, video, routing, caching, usage tracking, APIs, self-hosting. That is the direction. And it matters because the future of AI is not going to be only cloud subscriptions. People are going to want private AI. Companies are going to want controlled AI. Developers are going to want cheaper AI. Creators are going to want flexible AI, and open source projects are going to keep pushing more of this stack onto hardware you can actually own. Local AI is not the only project in this space, but it is a very clear sign that local AI is growing up. The first question was, can I run a model locally? The next question is, can I run my whole AI workflow locally? And if projects like local AI keep moving this fast, that second question is going to become a lot more realistic.